Welcome to Electricity and Magnetism Part 2, Coulomb's Law. As you can see in the screen, Coulomb's Law gives the force between two charged objects. And the form of Coulomb's Law is F, the force, is equal to K, a constant known as Coulomb's constant, times Q1 times Q2, where Q1 and Q2 are the charges on the bodies given in coulombs, divided by R squared, which is the distance between the centers of the charges. Notice this looks in form just like Newton's law of universal gravitation. So again, Q1 and Q2 are the charges on the bodies. In coulombs. We'll go over exactly what those are in a minute. And it's given the symbol C. R is the distance between the centers of the bodies. In meters. And K is Coulomb's constant, which is equal to 8.99 times 10 to the 9th Newton meters square per Coulomb square. Now, depending on the book you read, this might be rounded up to 9, so don't get confused. Now, the charges are in coulombs, as it says right up here. And we're going to use two different definitions for a coulomb. First definition we're going to use for a coulomb is 1 coulomb is equal to 6.242 times 10 to the 18th electrons or protons. Remember, the magnitude or size of the charge on an electron is equal to the magnitude or the size of the charge in a proton. They happen to be opposite in sign. Also, 1 coulomb is the amount of charge that flows when 1 amp flows for 1 second, or 1 amp second. Let's do a quick example here. Example number 1. Find the force between the electron and proton in a hydrogen atom if they are 0.53 angstroms apart. Okay, a couple of things we're going to have to keep in mind here. One electron is minus 1.6 times 10 to the minus 19 coulombs. 1 proton is plus 1.6 times 10 to the minus 19 coulombs. And 1 angstrom is 1.0 times 10 to the minus 10 meters. So 0.53 angstroms is 5.3 times 10 to the minus 11 meters. Okay, so we set up our equation. Force K Q1 Q2 over R squared. Force is equal to 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. Magnitude of the charge of the electron, minus 1.6, 10 to the minus 19 coulombs. Charge in a proton. And then finally the distance between the two of them. And we square that. Doing some of the arithmetic here. Minus 2.3 times 10 to the minus 28 Newton meters squared over 2.8 times 10 minus 21 meters squared. Now the coulombs squared in the denominator were reduced by the coulombs in the numerator, giving us a net force of minus 8.2 times 10 to the minus 8 newtons. Very small, but remember, the masses you're dealing with here are very small. Example number 2. We have two charges, a charge of minus 12 microcoulombs and 5.0 microcoulombs exert a force of minus 0.24 newtons on each other. Find their separation. In other words, find r, the distance between them. Coulomb's law. Substitute in our values. Now I know this is not the proper form, but I'm taking a little shortcut here, and I'm sure you'll bear with me. Doing some of the arithmetic. I'm sorry, this is not meters. This is a Newton. Got a little ahead of myself there. So we see that these two charges are 1.5 meters apart. I hope this helped, and please feel free to leave a comment. Let me know if anything's clear, not clear, more examples, fewer examples, anything I seem to gloss over and you didn't like. Thank you.